Why?
4.4 is the last section that will be on your tests. We'll go over the properties of logarithms. Have we all memorized how to convert from logarithmic form to exponential? If you forget, you can do the thing that, okay. If you forget what 8 times 7 is, just kidding. All right. Properties of logarithms. If you have a log of a product, we're going to split this up into the log of the same base times the first input x. Then we add the log with the same base b of the second input y. Any questions about this? Most common mistake I get is when you have a log of a sum, we can't simplify it. You see why this might be confusing? Log of a product on the inside, product on the inside, you can expand it into sum of logarithms, but if you have a sum on the inside, you can't do anything. Okay, so that's the most common error I get. Log of a quotient would become log base b of the top term, x, and this quotient becomes a subtraction instead of addition. Log base b of the bottom y. It's exactly like the inverse of exponents. Yeah. Finally, if we have a log of an exponential, we're going to bring that r out in front and multiply it by the log of the same base of x. Any questions about this? Expanding, it's an equality. So we could expand, but we could go backwards also. Sometimes we'd like to expand. Sometimes we'd like to consolidate into a single logarithm. So you do need to go both directions. Equality is bidirectional. In fact, what's going to be a lot more important is going this direction for solving equations, which we're not going to do until 4.5, the next section, which won't be on the test. Logarithmic equations will not be on the test. This section will be. Okay. X is equal to y if the log of x is equal to the log of y. This kind of is obvious, right? If you had something like x cubed is equal to y cubed, obviously x is equal to y, right? Because you could invert each side. So we can also do the inverse of each side and say, oh, the inverse of log base b would give us x, the inverse of log base b would give us y, so the inputs must be the same. You're doing the inverse operation. Okay, so those of you that did the homework and retained it, what's log base b of 1?
10? Base is 10, right?
The base is b, and the answer is 0, because b to the power of 0 is equal to 1. But what's log base b of b to the power of x? Very good. They're inverses. They undo each other. Is that true for all real numbers x? Can I raise a base to any power? The answer is yes, positive or negative or 0. And my answer to that will be a positive number. So this is b to the power of x. The range is positive. So I can plug that into log base b. So this is true for all real numbers, all x in the set of real numbers. Okay, what I should note is the opposite order is a little bit tricky. What if I have b to the power of log base b of x? This is equal to what? They're inverses. For whatever log base b does, b to that power will undo it, and we'll get x. But I cannot plug in all numbers for x. What can I plug into a logarithm? I can only plug in positives. Does this make sense? So log base b of x looks like this. If I plug in 0, it's no good. If I plug in negative, it's no good. My graph does not exist over there. I can only plug in positive x values to get a given y value. I can plug in this to get this y value. Let's practice these rules. Example 1, we want to expand this as much as possible. So do I want to deal with the exponents first or this multiplication first? Yes, deal with the multiplication first. And what's our rule here? I can split up into log base 3 of the first term. The multiplication becomes addition of log of the same base of the second term. Any questions about this? And then I do what next? So I'll call that log of product rule. We do sum of logs. And the next rule would be what? Log of, not quotient, of exponent. So I have 2 times log base 3 of the x remains on the inside plus log base 3 of y, and I should bring that 6 out in front. 6 times log base 3. Are there any questions about this? Yes. Yeah. If you just write 2 log, it means multiplication. It's okay if you don't write it. I wrote it just so people know what it means. Actually, I should probably talk about some notational stuff here, because a lot of people get confused about how to deal with logs and what are they. What does this mean? It means y. How can I describe, why do I use f instead of y? I can plug in values for x. So this is function notation. And in particular, this is not a product, right? It's not f times x. It's f of x. Does that make sense? Okay, so what we say is that f is the name of the function. So the same thing goes for log base 3 of x. This is function notation. So that means that this is a function whose name is what? Log 3. So it is one thing that cannot be separated from the x, right? That whole thing is one thing, is entire function. The reason why I bring this up is because in 4.5, we have equations like log base 3 of x plus log base 3 of x plus 1 is equal to log base 3 of, can I do this in my head? 1. Okay, so we're solving something like this. And every quarter, someone does this. Right? This makes no sense because it's not a variable. That's the name of a function. Right? Let's continue expanding. The next one. Should I deal with the exponents first, the product first, or the quotient first? Good. We do the quotient first. So let me write that. Log of quotient rule. Or maybe I could just write quotient rule. So what that does is it gives us log of the same base of something minus log of the same base of something else. So what's my first something? It's x squared, the numerator. What's my second something? yz squared. So logarithms are the inverse of exponentials. So what you should think of is anything that's on a denominator has negative exponent. So that's why the negative goes out in front for things in the denominator. Anything in the numerator is a positive exponent. Okay, the next one with this first term here, actually, I'll do that later. Let's leave that as is. Log base 8 of x squared minus, and now we're going to deal with the product. I'm going to make a mistake on purpose. not an accident like my multiplication tables. And I want you to find my mistake. It would have to have a parentheses to be squared to both. The base is just a z. Made a very subtle mistake. Yeah, that positive should be a negative in front of the z squared. So what's going on here is my variables y and z are in the denominator. So their exponents, their coefficients must be negative. So I did not distribute this negative sign like I should have when I expanded that. Okay, so this whole thing here, this whole term is this whole term, and I need to distribute that negative. Thank you. That one was not on purpose. Any questions about this? Yes, this expanded form. So after you do a lot of these, I hope you notice the pattern and can skip straight to the bottom and say, oh, I know it's going to be 2 log base 8 of x, and it's positive because it's on numerator. On the bottom, it will be a minus log base 8 of y because the exponent is 1. It's on the denominator, so it's -1. Then this one has a z squared, so because it's on the denominator, it's negative. And exponent is 2, so that's my coefficient. Log base 8 of z. But what you'll notice is there's a way to get straight from here to here with pattern recognition. I'd like you to be able to show your work. There's more than one way to do this problem. Any thoughts on what we might try first? Okay, so the quotient is inside of the radical. So my options are to rewrite and simplify the radicals inside, or to deal with the radical first as an exponent. So I'm going to rewrite this as log base 7 of x cubed over y to the what power? Square root is 1/2 power. So should I put that, do you want to simplify that expression first, or do you want to just take out the exponent of 1/2 first? I agree. Simplify, I think, is easier. So what does that mean? I'm going to write this as log base 7 of x to what power? Actually, let me not skip steps. So now I'm doing the numerator to that power, and I'm going to do the denominator to that power. So what's the rule of power to power? Close. That's further away. Okay, these are rules that we don't practice all the time, so it's easy to forget. Let's pretend it's x cubed squared. That's the same thing as what? X cubed times x cubed. Which x cubed is x times x. So I have altogether how many x's? So what's my shortcut? 3 times 2. I should multiply, what's 3 times 1/2? X to the 3/2 over y to 1/2. Do I do division or exponent next? Division, I'll have to have negative, and the denominator goes to the right of the negative. Log base 7 of the denominator is y to 1/2 power. The numerator is x to the 3/2 power. And my final step is what? Move the exponent to the front, and it's multiplied by that. Now, I don't have to write multiplication. I can write just log base 7 of x minus 1/2 log base 7 of y, but you have to understand its multiplication. Any questions about this? Example 2 is going backwards. This is the more important skill because we're going to use this to solve equations. If I have a logarithm times a constant, how do I undo that? This becomes my exponent. Log base 2 of y to the power of -3, which is the same thing as log base 2 of 1 over y cubed. So express as a single logarithm with coefficient 1. Coefficient 1 means it's a 1 in front, no numbers in front. It's coefficient of -3. So we're done. Yes, final answer should not have negative exponents. Should I write that note? Okay. Not have negative exponents. Now, would I mark you off for that? It depends. If it's a long problem, probably not. If it's a one-step problem like this, then yes, I might. Next step, I should do what first? Or next problem? Inside the parentheses, okay. Yeah, let's deal with the coefficient first and make that an exponent. Log base b of x minus, oh, wait a second. Let's keep the parentheses there so I don't mess up. Log base b of y squared plus log base b of z. So even though the parentheses aren't written there, they're inferred. That's what's being plugged in. And if there's no parentheses written, you assume only the next thing is in there. So I'm assuming only the y is in there. I'm not assuming this whole thing is in there. Next step is what? Let's go ahead and combine these into a single log. Log base b of what? Y squared times z. I still have the negative log base b of x minus this. And my next step is to combine these to make log base b of what? So the negative makes it into a fraction. On the top is the x because it's a positive. On the denominator, because this is negative, it becomes a y squared z on the denominator. So we expressed it as a single log with coefficient 1. Any questions about this? Okay, how do we combine these? Yeah, we deal with the exponents first. Ooh, do I take the 2 or the negative 2? You could do either. Either's okay. Which would you prefer? Do we have preference? Okay, I'm gonna take the negative 2. So that gives me 1/2 times natural log of x cubed. If I took the negative, then this becomes a plus natural log of y to the negative 2 plus natural log of z is still there. So the advantage of taking negative 2 is all addition, so I can combine those pretty quickly into the natural log of, and they're both products because they're both addition, x cubed times y to the negative second times z. If my final answer can't have negative exponent, x cubed z with y to positive 2 on the bottom. It's still there. And I don't have a coefficient of 1, so what's my last step? This becomes an exponent of 1/2 of the whole thing is really a square root. And the whole thing has to be under the radical. Any questions about this? Yes. It's an exponent of 1/2, and that means square root. Okay, so I teased you with this equation earlier. So how would you solve it? Is you would combine these into a single logarithm. What's the answer if you combine these in a single log? Log base 3 of x times x plus 1. If I have the same log on both sides, what that means is the insides must be equal. X squared plus x must equal 1. And then we just solve the quadratic. X squared, wow. Yeah. I guess I didn't make something that's factorable. How could I change this to make it factorable? So factors of -1. Yeah, maybe make it a, well, if we make that a 2. Factors of -2, that's factorable, right? What does it factor into? X plus 2, x minus 1. X equals -2, x equals 1. And we have to check. What's log base 3 of -2? You should know that at the top of your head. What's log base 3 of negative 2? Log base 3 of negative 2. It's undefined. You cannot plug negatives into logarithms. Extraneous solution. But I can find log base 3 of 1 plus log base 3 of 1 plus 1. That's okay. And I'll get log base 3 of 1. Okay, so that's what we'll be doing tomorrow or after the test. Not sure yet. The point is that there's a reason why we combine logarithms so that we can solve equations. Bless you. All right, everyone take out your calculators you'll be using on your tests. Do your calculators allow you to do log base 3?
But I think on some of our calculators, like I think it depends, but on mine, it's like on the very top right corner, it's like a log, and then there's like a white square and a.
Okay, so some of your calculators will allow you to do log base something of something. Some of yours don't allow that. So if it doesn't, you're going to need to memorize this change of base formula. Oh, this is a typo. This is a really bad typo. Should be a log base B. Scientific non-graphing. It's okay. This isn't too bad. So if I have log base 3 of 25, would you like to convert it to the natural logarithm or the common logarithm? You say the log that I want, base 10, of the inside is 25, and I divide it by the log that I want, base 10, of the old base. And that's going to be our formula. Log of 25 over log of 3 will be your answer. Shall we check? How do I do this? Windows, T, calculator. Okay. I can't change my base, so I'll do 25. That's not right. 25, that's log of 25, and I'm going to divide it by, what in the world? 25. That's log of 25, and I'm going to divide it by 3 log of 3, and my answer is no, not plus, equals. Okay, I don't trust this. What happened? 25 log of that divided by 3 log of that is equal to, oh no, what was it? Okay, change the base formula. Now that's equivalent to natural log of 25 over natural log of 3. You can use any base you want. Do you believe me? Let's double check. I feel like this should. Okay, 25 natural log of that divided by 3 natural log of that. Hey, same thing, right? The change of base formula works. Yay. Wait, what? Yeah. Let's review. What's the difference between log of x and natural log of x? Log base 10. And this is log base what? E. Very different. This one is the inverse of what? 10. Yeah. Which exponential? 10 to the power of x. This one's the inverse of what? E to the power of x. This word problem is going to be associated with section 4.5. Let me go over one homework problem that is a little tricky. The last problem. It wants me, without using a calculator, to estimate what numbers is this between, which consecutive integers. For instance, this is between 2 and 3, because 2 squared is less than 7, and 2 cubed, 7 is less than 2 cubed, 8. What I'm going to do here is I'm going to write this number, log base 3 of 0.06 And I'm going to say, I want to find which numbers is it between n and n plus 1. Remember that trick I said you can do that you don't like? We're going to use that trick. What does the inverse of log base 3? 3 to the power of log base 3 of 0.06. I'm going to do 3 to the power of n and 3 to the power of n plus 1. So I did 3 to the power of all three parts. Is everyone okay with that? Because I wanted to undo the log base 3. So what's the answer in the middle? 0.06. They undo each other. Is between 3 to the power of n, 3 to the power of n plus 1. Okay, there's something really subtle here that's going on. What does the graph of 3 to the power of x look like? It's strictly increasing. So what that means is it maintains inequalities. If one number is smaller, let's say a is smaller than b, because on the number line to the left, then because it's an increasing function, f of a will also be smaller than f of b. Does this idea make sense to you? So plugging all three parts into 3 to the power of x maintains inequality. That's not true for all functions, but if it's strictly increasing, it is true. Okay, 0.06 is 6/100ths. If I made that into 6 divided by 6, I would get 1. What's 100 divided by 6? You have your calculator? No, 100 divided by 6. 16.6 repeating forever, right? Okay, I would like to compare the numbers only on the bottom. So I'm going to write this as 1 over 3 to the negative n. And this one as 1 over 3 to the negative n plus 1. So really, I want to find out which number do I plug in for n to make this true. So I really want to compare 16.6 is between 3 to what power? So what power would be really close to 16? Okay, what's 3 to the power of 1? Okay, what's 3 to the power of 2? What's 3 to the power of 3? Okay, so I found it. 2 and 3, right? Because that tells me that this is 9 and this is 27. I know 16 is between 9 and 27. Okay, so my answer should be -3 and -2. N equals -3. My original logarithm is between -3 and -2. Are there any questions about this? Do I have time to do this word problem? It's pretty interesting. Have you ever heard of the Richter scale? Measures intensity of earthquakes. If my earthquake has this intensity, I just plug it into this logarithmic equation. I say m is equal to log base what? 10. It's a common logarithm, right? Log base 10 of, what's my intensity? Yes, 8,250,000. I naught is the smallest intensity that can be measured by our instrument. So these cancel, and I plug that into my calculator. Log base 10 of that number, for sake of time, the answer is about 6.9 is the magnitude of that earthquake. It's pretty bad. Okay, find the intensity of a 5.4 earthquake. So instead, now I'm saying the magnitude is 5.4 is equal to log base 10 I over I naught. So I convert this to exponential form and it would be what? 5.4 is equal to I over I naught. So I multiply both sides by I naught. And I get I is equal to 10 to the power of 5.4 I naught, which is what? 9 I naught. Compare the intensity of earthquakes from example 5 and example 6. Okay, so how do you compare two intensities? You divide them. So that would be 8,250,000 I naught divided by 251,189 I naught. The I naughts cancel, and this is written as 10 to the power of 6.9 over 10 to the power of 5.4, and we subtract the exponents to get 10 to the power of 6.9 minus 5.4, 10 to the power of 1.5 is about 31.623. It's 31 times more intense, a 6.9 than a 5.4. So if you experience a 5.0 earthquake, how much more intense is a 6.0? 10 times more intense because it's log base 10. How much more intense is 7.0 than a 5.0? 10 squared. 100 times more intense.